Number 1, doing the following constructions. I'm going to look at the first one. Parallel to the Gibbon line, going through point A. So we want a line that's parallel to this line, but we want it to go through the point A. So we can kind of visualize where this line's going to be. But of course a construction is using a compass, and I should see the arcs to support that construction. So the first thing you're going to do in this construction is you're going to draw a line from point A that goes through your line that's given. You don't have to try to create 90-degree angles. You're just trying to create 4 angles here, and what you're going to do is you're going to copy one of them. I always like to copy an acute angle as opposed to an obtuse one. So this is the angle I'm going to copy. So this construction is using the converse to the corresponding angles theorem. The corresponding angles theorem says if you have 2 parallel lines, and I'll put the symbol for parallel there just to show they're parallel, cut by a transversal, then the corresponding angles have to be congruent. So this angle 1 and this angle 2 would have to be congruent. The converse of the theorem says if corresponding angles are congruent, then the lines have to be parallel. So we're using that fact to create corresponding angles that are congruent, therefore making our lines parallel. So this is the first of the 2 angles that I'm going to create to be congruent corresponding angles. So what I'm going to do is I'm going to use the construction to copy this angle. This angle's vertex is at this intersection. I want the corresponding angle to have A as a vertex. So the first thing I'm going to do is I'm going to put the point of my compass at the vertex of the angle that I now have. I'm going to choose a setting on my compass that will allow me to draw an arc through both sides of that angle. And remember, I always do what's called a dry run first. Before I put my pencil in there, just make sure it's going to work. Then I'm going to either start above where I want it to be or below where I want it to be, so I can go in one direction with my arc. I don't go back and forth, just one solid fluid motion. So I have my arc through both sides of that angle. Everything I do with this angle, I have to do down here to create this one. So the point of my compass was on the vertex of this angle, so the point of my compass is going to go on what's going to become the vertex of my new angle. So my point of my compass goes on point A, and I'm going to use that same exact setting. Right now I only have one side of this angle, so I'm going to start on the other side of it just like I did up here. And I want to go down quite a ways because I want to make sure that I've covered the region that I'm going to eventually have a point for to draw that parallel line. So I wouldn't stop my arc up here. That's not coming down far enough. Remember where your line's going to end up is about right here. So the next thing I'm going to do, this is using the same setting here. I'm going to go and I'm going to measure the length of this arc right here using my compass, not numbers. So I'm going to put the point of my compass on one of those points of intersection, and I'm going to open the hole so it's on top of the other point of intersection. So that's what we call measuring that distance. Point of my compass on one, hole on the other. So notice where the point of my compass was, up here on this point of intersection on this side of that angle. So here's that side of that angle. Here's that point of intersection for this angle that we're creating. So I'm going to put the point of my compass on that point of intersection, and I'm going to use that measurement we just created to draw an arc that intersects the one I already have. This intersection of arcs gives me a point. Without intersection of arcs, I don't know where that point is. I can't just guess where it is. I've got to have it. So now that I have that intersection, I can connect that with point A and create my parallel line. There's the construction of the parallel line. So even if it doesn't look perfect, these are the things that we're looking for. Did you use the same setting here and here? Did you measure this distance here and make this arc right here? And then connect it to make your parallel line. Those are the congruent corresponding angles, which means these lines must be parallel.